Hey block building fans, this is Yancy from Yancy's Custom Bricks. Actually, I wanted to make the videos in stop motion style until the end, but well, it's impossible to find enough time for that. Not least because I make changes to the construction very often. Anyway, from now on I will mainly use time-lapse videos which I'll comment on. I hope you like the videos at least as much as before. As always, I welcome comments, so feel free to leave some. Of course, I would also appreciate a like or follow. As you can see, I used a few printed parts to install ball bearings. These are necessary to reduce friction. I have even had parts melt together on other projects because the friction was too strong. In this section I built the tensioning mechanism for the suspension cables. As both the nacelle and the counterweight will later be suspended in 4 pulleys, it is necessary to be able to tension each cable individually. The ropes are wound onto a small Lego winch, while a locking mechanism prevents them from unwinding again. The drive is also housed in the middle of the construction. It synchronizes the 4 drive wheels via a gearbox. Here I mount the first pair of the tires on one of the main axles. The wheels are perfect for moving ropes because of their grooves. And here the second pair. Then I add some noses for the later housing, but spoiler, I won't use it because I will change the construction again. Let's try if it fits on the tower head. Seems like it is fine. Okay, it's time to deal with one of the most annoying parts of the whole construction, the threading. I use a thin black yarn that I got from my mother a long time ago. Thanks, Mom. Now let's start with a test of patience. It took me many attempts to get the first thread through the Lego pins. And it didn't work without tools. But finally, I was able to test the winch and the locking mechanism. Then I had to unwind about 3 meters of yarn to thread the next cable. I had fewer problems with the second one and was able to wind it up quite quickly. Then I swapped the sides to install the last 2 cables. That was a bit tricky because the long threads quickly become knotted. To get around this, I started winding the threads on Lego rims. Almost all of them have a hole as standard, as if they were meant to be used as larger winches. But as you can see, this became the next test of patience. Well, that really took a lot of time. And remember, firstly, it's running fast motion here, about 30 times faster, and secondly, I cut out a lot of parts completely. As I was winding up all the cables, I noticed that the locking mechanism didn't function properly when the construction was turned upside down. The latches disengaged, causing the cables to unwind and lose their tension. To address these issues, I needed to refine and improve the design. I first tried replacing the locking levers with 90-degree connectors, which I intended to keep under tension with a spring. Due to limited space, I opted to use rubber bands instead. Since the available rubber bands were too large, I had to replace the 90-degree connectors with a type of rocker mechanism. The new design, held under tension by the rubber bands, ensures reliable operation. The setup keeps the latches in the correct position and prevents the cables from unintentionally coming loose. In the next step, I will estimate the final weight of the gondola to adjust the counterweight for proper balance. For this, I use a kitchen scale. Unfortunately, the display is difficult to film. First, we add the gondola. It weighs 462 grams. Then we add the LEDs that will be installed later. They increase the weight to 490 grams. Of course, the riders cannot be left out. The total weight is now 542 grams. Let's check the counterweight. In a previous video I filled it completely with steel balls. It weighs 686 grams. So we need to remove 144 grams to achieve balance. Okay, now it's perfect. Next we attach the counterweight to the gearbox by tensioning it against the sailing with a cable. I have already prepared the pulley part, as you can see. Nice, that's pretty sturdy. From here, the perspectives are slightly different, as the footage is from a live stream. I had the idea of adding a second tensioning mechanism that could wind and unwind the full length of all the cables simultaneously. This would simplify the later installation of the gondola. The challenge was that the space had already been allocated by a 3D printed cover. I had equipped it with hundreds of LEDs, so I was determined to use it. After struggling with various designs and not having enough space, I used rims that were smaller in diameter. In fact, they fit almost perfectly. The entire construction couldn't have been even a millimeter larger, but it just fit right. Here you can see the entire development of the tensioning mechanism at high speed. In reality, it took me about 4 hours to complete. All the cables are threaded through the outer pins and secured in the rims. Now we can test if the winding mechanism works as expected. And yes, it works pretty well. Fixing the future suspension points of the gondola wasn't easy. Unfortunately, I couldn't capture that on camera. However, You can see here on the red pins that the ropes were tightened under tension. Next, we lift the gondola onto the tower. It moves very smoothly. Now it's time to mount the main drive unit and add the missing guiding parts. After that, we can push the gondola to the top and secure it with 2 bricks. And finally, we can hang it into the cables. At this point, we open the locks and unwind the ropes. That worked incredibly well. Now we are connecting the rigged up test power source. Of course, the passengers still need to take their seats before the first ride. The moment has arrived. The first test run can begin.